This video is intended to go along with the lesson on adding and subtracting polynomials. And what I'm going to do is demonstrate algebra tiles using two of the problems from the attached practice set. So I strongly encourage you, if you linked over to this video from the lesson on adding and subtracting polynomials, that you also do the practice set so that you can see how this ties in and you can just add another, like a tool to your toolbox. So as I went over in the video, your x squareds are represented by area. And so this square has dimensions x times x, so the area of it is x squared. This rectangle, and this is better than my drawing in the video, has a height of x and a width of 1, so the area is x. And then we have the 1 by 1, and we use that to represent our units. So you can use algebra tiles to represent virtually all of your quadratics. You're only limited by the number of algebra tiles you have. If you have negatives, then you would use the red tiles. So in our first problem in the practice set, we have x squared minus 3x. So I'm going to collect 3 of the negative x's minus 4. So 1, 2, 3, 4. And this is what it looks like. So this is x squared minus 3x minus 4. That's how you would visually represent that polynomial using the algebra tiles. And we're adding to that 2x squared plus 5x. I probably should have used the horizontal one. So what do? I grab one of these ones again. This be on my game here. So we want plus 5x, and I believe we can just rotate. Yeah, so let's go up there and rotate them. That way they're all facing the same way. Okay, and plus 4. Okay, and of course we're using the positives. So negatives are represented by the reds, and then whatever's colored is represented by where that color is, that's positive. So, all right, now to combine, if you think about if you have a pile of Halloween candy and your friend has a pile of Halloween candy and you say to each other, let's combine our piles of candy, what you would do is you would just take all of this stuff and you would just dump it into one gigantic pile. So that's what I'm going to do. I'm just going to dump it all together. And so we have this lovely pile of algebra tiles. And here's what we do. We look for what are called zero pairs. So what I mean by that is if I take, now this is my big pile. This is my combined pile. It's beautiful. If I have a positive 1 and a negative 1. So I have 1 plus negative 1. That is equal to 0. And so essentially the yellow square and the red square cancel each other out, and we can remove them from the pile, and we know that this is still the same value. And if you notice, we've got all of those zero pairs. So what that means is that my positive 4 and my negative 4 are going to cancel each other out. So there's all 4 pairs. So we're just going to move those guys out of there. All right. And this takes longer. If you were doing this with an actual physical set of algebra tiles, you could do this much quicker. I'm explaining it, and I'm also working on a computer screen. Now, the same thing is true with the x's. So you can actually form what are called zero pairs of the x's. So a positive x minus an x, well, x minus x is 0. And so we can pull out these zero pairs as well. And this is the process of canceling stuff out. This is what we do when we're combining like terms. I guess the analogy would be something like moving around on the number line. If you're so far in one direction, you end up canceling out. And what I'm left with is 3x squared plus 2x. So 3x squared plus 2x. And that is my answer to that first problem. So that's how you would do that adding. Okay, so you just model each of your polynomials, dump them into one pile, and then look for those zero pairs. All right, now the other problem that we're going to work on is a subtraction problem. And so for that one, this is number 6 on the practice set, and this is going to be x squared plus 3x. That is my first polynomial, x squared plus 3x. And then I am going to subtract from that 2x squared plus 3x plus 5. 1, 2, 3, 4, and 5. So we're going to take this polynomial and subtract, trying to make like a minus sign with my mouse there, this polynomial. And this is where we want to remember what it means to subtract. Subtracting means to add the opposite. So what I'd like to do is take the subtraction problem and turn it into an addition problem. And I can do that as long as I add the opposite. So right here, if you look at these algebra tiles, it will say to flip. Well, watch what happens when I click on that and flip it. Now it becomes negative x squared. So that is the opposite. So what I'm going to do with this polynomial that I am subtracting is I'm going to take the opposite of everything. I'm just going to flip all of these things over to get the opposite. And again, this actually takes a lot longer to do on the computer than it would if you were sitting at your desk with a set of tiles. And in the lesson, this is the part where we look at that second parenthesis and we say we're going to add the opposite to all of this, and we have to essentially distribute the negative or distribute the subtracting, meaning you've got to make this entire polynomial the opposite of what it was. And now we can just combine like terms. So I'm going to dump them all into one pile and look for the 0 pairs. Well, now I've got a 0 pair with my x squareds. So x squared minus x squared is 0. Then we've got 3 pairs here of x's. Okay. X minus x is 0. And so we can kick all of those out. And what I am left with is negative x squared minus 1, 2, 3, 4, 5. Right? Now, what I have found is that a lot of students don't need to do this, that you guys are pretty good about being able to subtract it, but not everyone. And even if you're not struggling, this is a good visual to have because it does take something that's pretty abstract and make it concrete. It turns it into shapes. And we're going to come back to these tiles to do some much, much more complicated things. And it is helpful if you already have a pretty good idea of what algebra tiles are. So hopefully that those answers match up with what you got when you did the practice set, or they will match up for when you do the practice set. All right, and I will see you in the next video.